All right, so we're up to 2.5, pre-calc B, graphs of rational functions. Hey guys, the key to this is going to be this word asymptotes, which essentially is where the graph can't cross. So generally speaking, it's like this. Like if I say, hey, there's an asymptote, and maybe a graph will come in and try to touch it, but it just can't. Don't know how much you worked with this in Algebra 2, but this is going to be the general idea today. So this says find the domain. Well, in this case, I'm definitely going to look in the denominator, and I'm going to notice x cannot equal 4. So if I was to go like this and look at it, x cannot equal 4 is 1, 2, 3, 4. And there is the asymptote. So the domain x cannot equal 4, said in a pre-calc kind of way, is negative infinity all the way up to 4, and then 4 all the way up to infinity. Okay, so this is a fancy way of saying it in pre-calc. Now in this particular sample problem, I'm going to show you something, maybe how to use your calculator to graph things. So I'm going to go to y equals. Well, I've already got it written in there, but part of the lesson is how to type it in there. So I'm going to go 1 and then divided by. Now, if I typed in x minus 4 right now, the calculator might have problems. So I'm going to use parentheses. Now, I don't know if you can see this or not. I really don't know, but there's a little kind of a yellowish green X right there above this button. And so I'm going to go ahead and I'm going to type, see if I can show you what I'm talking about. I have to hit the green button, and then this, and then see that types in my x, and then I'm going to go minus 4, and then end of parentheses, and now I'm going to hit graph. Now I do have my window set at 10 by 10. I'll show you what I mean by that in a minute. But as you can see, if I was to draw a vertical line right through x equals 4, neither of these, the left-hand side wouldn't touch it, the right-hand side wouldn't touch it. So that would be an asymptote. Interesting little graph there. So literally it would come in like this, and then it would come in like this, just above the x-axis, and then it would try to go towards it, and it can't. Now there's a lot of reasons why these graphs are the way they are, but for now we're just going to stop right there. So this says find the domain of the given function. So we look at this and we say, hey, there can't be zeros in the denominator. And if that can be factored, I better factor it. And that's a difference of 2 squares. Hopefully you remember that from Algebra 2. So x cannot equal 2 and x cannot equal negative 2. Well, if I looked at the number line and I thought about that, I'd say there's my negative 2, there's my 2. And so there's the hole, and so that means that x can be anything over here, anything in between here, and anything over here. So I would say it, negative infinity all the way up to negative 2, together with negative 2 all the way to 2, together with 2 all the way to infinity. Now because x cannot equal these things, if I was to draw this graph, my asymptotes would be x equals 2 and x equals negative 2. Remember, vertical lines are always x equals some number. Okay? All right, now move on to this one. This is factorable, so we factor it. X minus 6, x plus 2. I'm not worried about the numerator because I'm only concerned where the zeros are in the denominator. So here I say, hey, x cannot equal 6. And x cannot equal negative 2. So again, if I drew a little picture, my negative 2 would be over here, my 6 would be here, x can be anything over here, x can be anything in here, and x can be anything here. So I'd say negative infinity all the way up to negative 2, together with negative 2 all the way to 6, and then from 6 all the way to infinity. Now what are my vertical asymptotes? Well, it's what x cannot be, so they would end up being x equals 6, and then x equals 2. They would be lines, just like this dotted one, that the graph would never cross. And so now it says evaluate the limit based on the graph of f shown. So now they're just giving you the graph, and they're saying, okay, this gets a little confusing. And again, I wish I could zoom in on this, but right here, this is saying, and I want you to look very carefully, this is saying as x approaches -1, now there's an extra little negative right there, from the negative side. Now, that means if we were like thinking of the x-axis, and there's my 0, there's my -1, it's saying move along the graph left to right. That's what this is saying. Towards the asymptote, which happens to be -1. So if I traveled along the graph from left to right, I'd be going down. So my answer would be -infinity. So -infinity. This means move towards the asymptote, -1, which is that dotted line, from the positive side, which means right to left. So I start out on the right, go towards the asymptote, and look, it's going up. So my limit for this one would be +infinity. Okay? This one tells us to graph. Now, what I'm going to do is just say, all right, let's start right here. And we know that x cannot equal 2. So we know that our asymptote is going to be x equals 2. And that would be right here. So I'm going to make it dotted. And so here's the deal, guys. I'm going to go ahead and let you practice with your graphing calculator on these. So I'm going to go on. I want to clear that. I want to go here. I want to clear that. And I'm going to go 1 divided by parentheses. Get my x in there. -2. End of parentheses. And I'm going to hit graph. And my asymptote should be right at 2. And you see there's a left-hand side and there's a right-hand side. So this comes in just underneath the axis, goes towards the asymptote, and then goes down. And then on the top-hand part of the x-axis, as you can see, it's going to go like this, and then go like this. If you don't have a graphing calculator, you can go to desmos.com and it will do the same thing for you. Okay? And so this says describe the behavior at the vertical asymptote. So you got to kind of make up your own math problem, which means we're going to find the limit as x approaches, watch this, 2 from the negative. And we're going to find the limit as x approaches 2 from the positive. In other words, we're going to follow this left to right towards the 2, left to right from the negative side, and it's going down. So that'd be -infinity. And this one right here, approach the asymptote from the positive side, means come here and then go up. So that would be infinity. Okay, so this guy, let's try it. So we're going to get our y equals. I want to clear that one out. This one's different. This is going to be -1 divided by, and I'm going to have to go x, and where is that? There we go, squared, and then I'm going to go to the right. See how it made me go to the right there, and then -9, end of parentheses. I'm going to graph that. And I want you to notice there's an asymptote at -3, and there's an asymptote at 3. Hopefully you guys can see that. So if I was to take that and go, well, where did that come from? I'm going to put this aside here, leave it so you can see it. If I was to factor this and go x minus 3, x plus 3, I would say, aha, x cannot equal 3, and x cannot equal negative 3. So 1, 2, 3, I know there's a asymptote. That's just a little space that the graph, mathematically, it's impossible to cross over that because those are impossible undefined values for x. And as you can see on the graph, it goes like this, and then it goes like this, and it's more of a flat curve, but I kind of was in a hurry there, I apologize. And then this is going to go like this. So let me fix this just a little bit. It's kind of like that. I know it's not a huge change, but all right, so now we got to talk about the limits. So watch this. The limit as x approaches, look at this one, negative 3 from the left means travel along this, and it's going to go down. So that's negative infinity. However, I got to go towards negative 3 from the right, which means follow this graph. That's going to go up. So that's positive infinity. So you just make the symbol for infinity. But I also have this asymptote. So I got to figure out the limit as x approaches positive 3 from the negative side, which means you're coming from this way and it's going to go up. So that would be positive. Then you're going to go limit as x approaches 3 from the positive side, which means here's my asymptote. I'm going to come at it and go screaming down. So that's negative infinity. All right. And what's on the back here? That's it. That finishes off 2-5. Oh, before I close this out, I do want you to know that we could, instead of using our calculator to graph this, we could just plug a few things in. For example, I would want to know what like negative 3.1 would do if I was to stick that in my calculator, square it, subtract 9, and then figure this out. You would get a negative, huge number down here. And you can experiment with a whole bunch of these numbers. For example, you could plug in negative 10 and, you know, for x, and think about it. Negative 10 squared is 100. 100 minus 9 is 91. Negative 1 over 91 is going to be this small little decimal. So this is supposed to come up here, and it's supposed to be just barely underneath the x-axis. So if you just plug a few numbers in, it'll help you understand why this graph ends up being the way it is. But we're not going to take the time to do that. We just don't have time on this video. All right. Hopefully that makes sense. But go ahead and bust out your graphing calculator or log into Desmos.com to figure out what these drawings really look like.